you again.
Okay, thank you.
Take one.
We're working on equilateral and isosceles triangles now. Okay, now, first tell me, do you remember what an equilateral triangle is? All three sides are equal, so it's a triangle with, how do we say that as geometers? Thank you. Well, I could have used a symbol, couldn't I? Alrighty. Well, if a triangle is equilateral, we're talking about the sides, right? What else do we know? If we know that a triangle is equilateral, what else do we know? That it is also equal angular. Okay, so all that means is that the three angles in it are congruent. If a triangle is equal angular, then we know that it's also equilateral. So we should never have to tell you both. We should only need to tell you that if it's an equal angular, then you know that the sides are going to be congruent. If it's equilateral, you know that the angles are going to be congruent. Okay. Now let's talk about the parts of an, I'm sorry, let's go back. What's the measure of each, how did you get that? 60 degrees. Okay. We know that the entire triangle, the sum of the interior angles is 180. There's three of them, so we divide that 180 by 3, and we get that 60 degrees. So each of these angles has a measure of 60 degrees. So we expect you to know that. Now let's talk about isosceles. Let's talk about the parts. What are the legs of an isosceles triangle?
SR.
Tell me SR and
ST.
so how would you identify legs? Okay, so what if the isosceles triangle is like this? They're the, thank you, they're the congruent. Thank you very much. All right, now what's the base of this triangle that we have presented?
RT.
And how would you describe the base of an isosceles? Thank you. Now remember, Ali, if it's upside down,
Yeah.
okay, this is still going to be our base. Okay? No matter how it's acclimated. It's the base. I love the smartboard for this. Over here, what's it called? What's this? Okay. Down here, what's it called? Okay, so no matter which way it's acclimated, it's still the base. Okay, we're going to identify the parts of a right triangle. What are the legs of this triangle here to the left?
QS.
Yes, Q.
QS.
Okay, let me ask one person at a time. Nacelle, you're talking. What are the legs? QS here and QR.
The QR actually is like community.
Raven? Oh, okay, I'm glad we're having this conversation. Anybody else see the
Yeah.
legs of the right triangle? Okay, I'm going to tell you it's not QS. Yes.
Which one?
We're identifying the one on the left.
Okay, QS and
Okay. The reason that we're tempted, do you want to guess? Go ahead, Judith.
SR and QR.
Yes, why are we, okay, let me tell you why I think you're exactly right. SR and QR. And let's talk about why those are legs. The reason I think people are tempted to say QS and QR is because you think of legs, when you're walking, yes? But the legs in a right triangle are actually the sides that make up the right angle. That's how I remember it. So what would be the legs in triangle VTU?
TU.
Thank you. So TU and VU are legs. Very good. So now what is a hypotenuse? Now I want you all to think about it. Hopefully you've seen it before. What's a hypotenuse in a right triangle?
Q.
Okay, and why do we call QS a hypotenuse? How can we identify that QS is the hypotenuse? Describe a hypotenuse. It is definitely the longest side of the triangle, so I'm going to put that down here. But how do I know that that's the longest? It's not congruent to any other legs. That's any other sides. Yes.
Is it congruent to the two sides?
No. Oh, that's an interesting point, but no, it isn't. Yes, Brandon? Okay, it's a segment in the triangle. Now, if I asked you, since someone, I think it was Isosceles, told us that QS is the hypotenuse, if I asked you to describe to a kindergartner what is the hypotenuse on that triangle, how would you describe that? Oh, interesting. So someone says it's the one with the tick mark. What I want you to get into the habit of saying is that the hypotenuse is the side that's opposite, because that's the word we started working with. It's opposite the right angle, and it's always the side opposite the right angle. Mm-hmm. So on triangle VUT, what is my hypotenuse? VT. And I have gotten into the habit, and I encourage you to do the same thing, to draw an arrow from your right angle to the side that it hits, and that's going to be your hypotenuse. Question?
What does the line stand for?
That must have come from, that must have come from another problem where they wanted you to know that those hypotenuses had the same number. But it's not relevant to what we're doing right now. Catherine asked what these tick marks were for. What do these tick marks tell you, though? When I put a mark like this on the side of a triangle, I'm telling you that these lengths are the same. But on this one, it doesn't matter. They're two separate triangles. It was probably taken from another problem. Yay! The base angles theorem. What kind of triangle is ABC? Thank you, it's isosceles. How do we know that it's isosceles? Okay, you see those red tick marks there telling you that AB is congruent to AC. Well, if two sides of the triangle are congruent, then the angles opposite them are congruent. So what we do is we put little arcs in the angles, and this shows congruence. theorem that you should remember for isosceles? The base angles theorem. Because their legs are congruent, their base angles are congruent. Now remember, by definition, the base angles are the angles whose shared side is the base of the isosceles. So if, this is the geometry representation, if segment AB is congruent to segment AC, then what would I say based on the base angles theorem? What can I say about the angle measure? Okay, can we write it? Give me the words. Then what? Okay, we talked about the shape here. Segment AB is congruent to segment AC. Then angle what? Angle C is congruent. Thank you. Now in this case, we can name those angles with one letter. But in most of the cases that we're going to be doing soon, you're going to have to name those angles with 3 letters. But one letter works for now. Okay, now do you remember what the converse is? What do we do with the converse? Thank you, everybody who crossed your arms. We switch. So if we're switching, here we talked about if the sides are congruent, then the angles opposite them are going to be congruent. So if we switch that, I think we're going to then be saying, if the angles opposite the sides are congruent, then the 2 sides of the triangle are congruent. Let's see. If 2 angles of a triangle are congruent, then the sides opposite them are congruent. And I know you probably look at that and say, no duh. So let's talk about it in a mathematical way. If angle B is congruent to angle C, then what? Also, segment AC is congruent to segment AB. Anybody lost? Everybody good? Let's keep rolling. Because now we're going to do some problems. We're going to be finding the unknown measures. And we have to say which theorem we use. In number A, letter A, I'm so used to saying number. What kind of triangle is triangle ABC? Isosceles, that's correct. What do we know about isosceles triangles? How many? 2 sides, which we call legs. It has 2 congruent legs. It has a pair of congruent legs. So, since these legs are congruent, what do we also know? What kind of what the angles opposite them are? Okay, so bless you. Which angle am I going to indicate is congruent to which angle?
The basis
Angle C is congruent to what?
angle A.
Okay, so if angle C is congruent to angle A, will that help me find the measure there? What is the measure of angle C? 50. So the measure of angle C equals 50. Yeah? That's because we see these tick marks. The angle opposite this side is here, and the angle opposite this side is over here. These 2 have to be congruent. Those are called what in an isosceles triangle? What is that called? The base. Those are base angles. Because there's another angle in the isosceles, right? It's up here. How do we find that measure? Yeah, thank you. Why'd you say minus 100?
Because 50, 50, 400.
Thank you. 180 minus 100. See how we have these two? These 2 add up to 100. And what did you know the sum of the interior angles to be?
80.
It has to be 180. So if we've already used 100 of it, we only have 80 degrees left, which is this angle. Perfect. So using the triangle sum theorem, we knew that the angles had to be 180, sum to 180. And using the base angles theorem, we had to know that that was 50. Yes.
So then, for the answer, would you just write measure angle B equals 80?
Yes. Thank you. All right, we're looking for what here? We're looking for a measure of a segment. And what's that segment? What's another name for that segment? DF. And what is it in terms of that shape? What kind of shape is that? Isosceles triangle. Very good. And what part of the isosceles triangle are we looking for? It's a, someone said it. Was that you, Vinny? Who said it? You did? What is that called? DF? Someone said it.
Leg.
Leg. So we're looking for leg DF. What do we know about the legs of an isosceles triangle?
They're the same measure.
They're the same measure. So what then is DF going to be?
DF equal 5.
And why do we know that? What's the theorem called?
You don't put the line at the top, yeah.
The converse of the base angle. Aren't you rocking? That's right. Because we know the base angles. If the base angles are congruent, then the sides opposite them are congruent. Did you hear her? She's rocking it. Yes, Catherine.
Why
I'll
is it
answer
that,
that question.
why is it that on other problems they put a line over it?
Yes, why is it? Somebody tell me for a lollipop. Why did I not put a line above DF here? What does that mean? Doesn't this, what does it mean when I don't put a segment above it?
So it's for the leg and not
No, it's still, when, this is upsetting. When you see two letters with nothing above it, it's saying the measure or the distance. So the measure of DF is 5 centimeters. And this is why a lot of times when you're seeing on a test or a quiz, when they'll say find DF, so this is the measure of DF. That says the measure of DF. If you have a line above it, you're talking about the shape. If you don't have a line above it, you're talking about its measure. Make sense?
Yeah.
Try to remember that. Questions?
So you use like the degree, like when you're trying to find the degree of something, that's when you put the line.
Okay, we will never find the degree measure of a segment. What are degree measures? When we're talking about degrees, what are we talking about?
Angles.
The distance between two sides of an angle. All right, everybody, look at number C. If you still have a question, I'll talk to you. Letter C. Sorry. What are we looking for? What? Oh, say it to me so that I know what you're talking about. Thank you for those of you who said angle H. We're looking for angle H. So we're looking for the measure of angle H. And do we know it?
Yes.
And how do we know that it's 60?
Because
60 multiplied by 3 is 180.
All right, so if we take the sum of our interior angles and divide them by 3, we get 60. But how did I know that they were going to be the same? These tick marks mean that this triangle is what? And equilateral triangles are always equiangular. Awesome. Let's keep rolling. Questions, anybody? Am I still rolling? Should I still go? Okay.
I
Prac-
think at least the first one was.
Okay. All right, now didn't we already do this type of problem? Ah, that's what you want to call it. What? This is the, isn't this the exterior angle theorem? Yeah, we call it Radcliffe. If you think about it, It does look kind of like a rat. Yeah? So can someone help me out? Talk me how to set up an equation.
For those of you that have your heads down, if you're not paying attention, you're not going to know how to do this, and we're about to make you do these problems on your own, so you need to pay attention.
Okay?
Find the epsilon first.
Hmm? Oh, wait, we can't. How can we find the x value?
Since you already have the degree
180
of the tail is 100.
You get a drink of water, get a drink of water.
Okay.
Minus 115, you'll get the 1, right? So
Okay, wait a second. Tell me the numbers you said again. I'll write it.
180 minus 150.
Okay. Okay, why didn't Isosceles say 180 minus 115 to find this angle here?
Because the segment, the base is equal to 80.
This whole, that's right, this whole angle, this linear pair adds to 180, and the exterior part we know is 115. So to find what's left over in here, I'm going to have to subtract to see what's left over from the 180. Let's do it. Did everybody get 65? Okay, so if this angle right here is 65, look at it for a minute.
Excuse me.
You have to take
I'm sorry. Wait 1 second. Don't you say anything. Everybody look at it for a minute. What Isosceles says is true. We have a tick mark here, and we have a tick mark here, which tells us what, Tori?
I'm just gonna say the answer.
Which answer?
For y.
Okay, but I want to know what x is first.
X is
And how do you know that x is 65? Okay, so if our legs are congruent, then what do we know? Ladies. These angles equal each other, so x has to equal 65. All right? Does everybody see how this is 65? So it looks like we're not doing anything with rats, are we?
Nope.
No, we're not. Okay, so we know that x is 65, and this angle is 65. How did we find y? Catherine, talk to me.
You add both 65s together and then subtract 180 by that number.
Okay, so if I were writing an equation for Miss Somerville, I'd say 65 plus 65 plus y equals 180. Now you don't have to do it this way. But if you do this, you won't ever make a mistake. I think you were right, Catherine. If I had just subtracted 130 from 180, I would have gotten that my y is 50. Everybody see it? Now, I encourage you strongly to put your three angles here, because right now we had very simple numbers, but when you do expressions, it's a little bit more complicated. So get into the habit of saying the first angle plus the second angle plus the third angle equals 180. I'm sorry, darling. It's open. Not here. Did you want me to do the next one or for them to try? Try this next one on your own. Should I pause it? Let's see. Sorry.
It's not that, no, sometimes it like disappears to the bottom.
This is second time in a row.
Okay, so please make sure that you have all the answers to this, even if you didn't finish. The takeaway from this is that every problem you do with triangles for the next 4 months of your lives, because that's all we're doing is triangles, every one of them is different. You need to pay attention, okay, and figure out, what do I need to solve this problem? I know it's isosceles, then I know the base angles are equal, okay? I know that it's equilateral, so I know that the measures equal 60 degrees. You're going to have to deposit all this stuff into your memory and constantly recall it, because I'm going to give you a different problem each time,
And
Okay?
I think a good example was that one when we started, like it was,
Yeah, it looked like rat poop, but you couldn't solve it, right? Because you had two variables. All right, so you're gonna have to try. That's the hardest thing about geometry is interpreting the diagram and then taking all the pieces that we've given you to understand which method to use. Okay? Pretty good? Questions? Concerns? Okay.
Oh,
Yes.
for
Go ahead.